In this tutorial, we're going to show you how to use the Auto-Inlay Toolpath feature. This allows you to compensate for the tool radius when cutting parts out that you want to insert into other parts. In our example, we want to take the letter E on the left hand side and we want to insert it into the pocket of the letter E on the right hand side. Now, because of the radius of the tool, if you are using the standard profile and pocket toolpaths, this will cause problems where you have sharp corners on either the external or internal areas depending on which one you are cutting. And the Auto-Inlay Toolpath takes into account the tool radius and rounds off all the sharp corners, allowing you to have two shapes that will slot together without any problems. So let's go to File, Close, and so let's start by going into Create a New File. So here we're working with a single-sided job. The width of this is going to be 10 inches, the height is going to be 6 inches, and our material thickness is going to be 1/2 inch. I'm going to set as a 0 position off the material surface, XY in the lower left-hand corner, and we simply go ahead and press OK. So let's go into the Draw Text tool to create our two letters. Okay, so here I can see the size of our parts, make that a little bit bigger, so I'll make that 4, and I'm just going to click over here to put it on this side of my job. And we're going to go with the Arial font, and I'm just going to type in the letter E, make that bold, close out, got my text. Take that text, press Ctrl and Alt to create a copy, but we're keeping it in line like so, and there we have our two letters. So for this letter E, I want to cut it completely out of my material. And the letter E on the right hand side, I'd like to create a pocket for this letter so that our E cutout can slot into the pocket E. Now before we go into the Auto-Inlay tool, I just want to show you the problem that we have if we just used a standard profile to cut the letter out and a standard pocketing toolpath to create the actual female insert. So let's switch over to the Toolpaths tab. Just going to go into the material setup. Here we just want to check over settings, ensuring they're safe and appropriate for what I'm doing. Okay, so I'm happy with that, so we could go ahead and press OK. So we're going to go into the profile toolpath. I'm going to start by selecting the left letter E. This is the one I want to cut out completely. So here we've got our vector selected. Start depth is going to be 0. Cut depth I want to cut all the way through, so we'll type in Z equals, and then it will remember the 1/2 inch thickness that we set in our job setup form. Then we need to select a tool, so we use the select option. Here I want to use a 1/4 inch end mill. Go ahead and press OK. And we're going to machine that on the outside of our vector, and then if we come down to the bottom of the form, we're just going to give that a name. We'll just call that one Profile, press Calculate, and then what we could do is we could go ahead and preview that toolpath. Okay, so that's what this one will look like. So going back into the 2D view, and we'll just close out of the preview toolpaths form, we're going to look at creating the pocket for the right E. So with this E selected, we're going to go into the pocket toolpath. So here we're going to have a start depth of 0, and we're cutting down 1/4 inch so that this E has a little bit that's actually raised above the surface of the pocket. Then we're going to select a tool, so we need to use the same tool here, so we're using a 1/4 inch end mill. We'll just do that in an offset strategy. We'll just call that one Pocket. Simply go ahead and press Calculate, and then let's go ahead and preview that toolpath. So to help us see a little better what's going on here, I'm just going to apply a toolpath colour. We're just going to go for this orange colour here. I'm also going to tile our windows so you can see the 2D view also, switch on those toolpaths, and we're going to switch this from a wireframe to a solid preview here. And so we can see in our previews the issues that we face when cutting parts that are supposed to fit into other parts using the standard toolpaths. So if we just zoom in on the 2D view, okay, so we're looking at both of the E's here. Now, when we're cutting the outside part, we will always get radiused internal corners because of the shape of the tool. And when cutting inside the part, we're always going to get sharp internal corners, but we're going to get radiused external corners like the ones that you can see over here. And so we really are presented with a mismatch of internal and external corners when we're trying to slot one part into another. So we can see where we have a nice sharp corner here. If we was to slot this letter into this part, it's not going to work because we have a radiused internal corner here. Likewise, this section here, when we cut the letter E out, we're going to have a radius internal corner, but the actual pocket presents itself with a nice sharp internal radius here. And so this shows the problem that we're trying to overcome when using the Auto-Inlay tool. When we use the Auto-Inlay tool, the software knows that we want to make one shape slot into another, where it rounds off the corners based on the tool geometry that we are using. So if we just close out here, and we're just going to delete all of these toolpaths. And then if we go into Preview Toolpath Forms, reset that preview, close out, maximize the 2D view, zoom to fit, and now we're going to look at profiling and pocketing the two E's, this time using the Inlay Toolpath option. So we're going to go into the Inlay Toolpath. And to start with, we need to specify the type of inlay that we'd like to create. Okay, so we have straight and pocket, or we have stepped and hole. Now, in our example, we're going to start by just looking at a simple straight and pocket inlay toolpath to begin with, and then we'll look at an example afterwards where we can look at the stepped and hole options. So, we need to select your letter, and then we're going to specify whether we're going to create a straight male inlay or the female pocket inlay. In this case, I'm going to go with the straight male inlay. So I'm going to go into there, and you can see that the form is very similar to the profile toolpath form because it's practically doing a very similar operation, except it's going to take into consideration the fact that we may have corners in our geometry that need rounding off. Okay, so here we put in a start depth. In this case, we're going to go 0. Cut depth is going to be 1/2 inch. Then we need to specify a tool. So here I'm going to go with a 1/4 inch end mill. And it's very important that we use the same tool for both the male and the female inlays, because the software is going to round the corners based on the radius of the tool that we're using. So that is very important that we use the same tool for both male and female inlays. Okay, so we've got a 1/4 inch tool in there, and then we could simply go ahead, give that a name, call that male inlay, and then press calculate. And so let's tile our windows, and then if we go ahead and preview that toolpath, if we just zoom in on the letter E, we can see that it's rounding off all of the external corners and automatically rounding off the internal corners. So again, if we take a look at our solid preview, we can see the effect of that toolpath here. So rounding the external, also rounding off the internal. Okay, so that's exactly what we want here. Right then, so let's have a look at creating the female inlay. So we're going to go and close out of the preview toolpath form. We're going to select this vector here, and then we're going to go back into the inlay toolpath, where this time we're going to specify a female inlay where we're going to create a pocket. So here our start depth is at 0 and the cut depth we're cutting down 1/4 of an inch. The tool, remember we must use the tool that we used for the male inlay. So we're going to put in the 1/4 inch tool in there, press OK, and then we'll do that in an offset strategy. Just call that one pocket inlay and then simply go ahead and press calculate. So let's go ahead and preview that toolpath, and then again let's just put in toolpath color there just to fill that out so that we can then zoom in and look at the difference. And in here I'm going to switch on the toolpath so we can see the solid preview in the 2D view also, and here we can see that it's rounding off all of the external corners as well as the internal corners. So now we have a matching of the rounded corners where one can successfully slot into the other one. And that's all been done automatically by choosing the Auto-Inlay Toolpath option. Now, one thing to consider is the practicality of machining inlays, and that's the fit of the male part being inserted into the female pocket inlay. We do need there to have a very small difference in sizes in order for one to fit comfortably into another. If we cut them both to the exact size that we have here, then we're going to find it very, very difficult to slot the parts together. And so the way that we overcome this is to apply an allowance to the toolpath, where we slightly undersize the male part or slightly oversize the female part, and that will give us a difference between the two to allow one to slot into the other comfortably. Now, the allowance can be applied to the male, the female, or both, and typically the best method and probably best practice would be to cut the male part first, and then we can use this male part to then test the fit of that part being inserted into the female pocket, where you can then overcut the pocket until you get the required fit. So if we go back into the female pocket toolpath, you'll see that we have a pocket allowance option here. And so here is where we can specify our overcut. And this value will really vary depending on your material, the accuracy of your machine, the size of the tool, and any finishing that you may apply to your material. So we're going to be quite conservative here, and we're going to oversize this pocket by 0.02 of an inch, okay? And so if I go ahead and press calculate, you would have noticed in the 2D view here, if I zoom in, we are now overcutting that by that 0.02 of an inch, and so our pocket gets slightly bigger so that our male part should fit nicely into that pocket. So at this stage, what you could do then is simply go save out those toolpaths to then cut that on your machine. Now, in this example, we've cut both the male and the female parts out in the same session, and this really is quite unusual, as you'd normally apply this technique to two separate sessions using two separate pieces of material, where you just need to make sure that you are using the same tool for both the male and the female session. So for the purpose of this tutorial, it's easier just to demonstrate the two in the same session. So if we just go to File and then Save As, and then we're going to call this one Inlay Guide 1, press Save, and then you can access that from your project folder. So now let's take a look at the other two inlay options. Now, rather than cut a pocket out for the female part, we're going to show you how we could cut this as a whole, so we're cutting all the way through, in which the male part of our inlay would have a step on it that is then pushed through the back, and it locates against the step shelf, which is then glued together. And so you'd want to use this option if you wanted to create push through letters. For example, if you wanted to create a sign with an aluminium facing and then pushing acrylic letters through, that could then be backlit. So if we just go ahead and delete all of these toolpaths, we're just going to say delete all visible, and we'll just go ahead and tile our windows and then just reset that toolpath preview. So let's select this E here, and we're going to go back into the inlay toolpath. So we're going to work with the male inlay, so the insert part, except this time we're going to look at applying a stepped inlay. So here again, this is very similar to the profile toolpath form, except now we have an additional section here where we can specify a stepped depth along with a stepped width. So here we're going to go with the start depth of 0, and then we specify a cut depth. So here I'm going to go 1/2 inch. The tool we're going to use, again, we're going to go with the 1/4 inch end mill in there, press OK. And then we move on to the stepped depth and the stepped width. So for the stepped depth, I'm just going to type in a little calculation in this box. So we're going to say Z, which we know is 0.5, minus 1/8 of an inch. So type that value in, 0.125. And then we're just going to go ahead and press equals. Okay, so this is going to leave a 3/8 inch thick shelf or a step for the actual depth there. The stepped width, so this is the width around the outside, so we're going to go with a value of say 0.2 in here, and then we could just work our way down, give this a name, we'll just call that one stepped male inlay, and then simply go ahead and press calculate, and then we could preview that toolpath, see how that looks. Okay, so if we just maximise the 3D view, we can see that step or the shelf in there. Okay, so this is basically the mating surface, and that's going to slot into the hole that we're about to create now. And this is where you'd essentially just glue it together. So just put that back in Z, and then we'll tile our windows and we'll just close out of that toolpath preview. Now we'll look at creating the hole for the female part. So with that vector selected, let's go back into the inlay toolpath. This time we're going to select the hole option. So the start depth here we're going to have at 0, cut depth cutting all the way through, so Z equals 1/2 inch. Tool, we need to select a tool, we want to make sure it's the exact same tool that we use for the male part, which is the 1/4 inch end mill. Go ahead and press OK. Then we choose how we want to machine it, any offsets. So again, we want to put in a little bit of an offset in here just to make sure we're overcutting it slightly so that our parts can fit in nicely. So we'll go with 0.02 in there, and then we could simply give that a name, hole inlay, and then press calculate. And then if we just take a look in the 2D preview, so you can see we've got our offset, and then if we go ahead and preview that in the 3D view, if we just maximize the 3D view there, double click on this waste material, and there we have our two parts. We've got our male stepped part and we have a hole in here. And so this piece here would be inserted through the back of the hole and fixed into place using this step that we applied to the male inlay. Now in reality, the material that would machine the male part from would be thicker, so that the letters would protrude through the actual female hole inlay. So as I mentioned before, we would be cutting these two inlays out of two separate materials, where the hole was being cut out of a thinner piece of material, so that when I push the letter through this area, the letter would come clean through and then it would stick out on the front surface. So here I'm just showing you this in the same piece of material for convenience. Okay, so let's go ahead and save this file out so you can take a look at the two files. So go to File, Save As, and in here we're going to call this one Inlay Guide 2. Press Save and you can access that from your project folder. So the key things to remember when using the inlay tool is to make sure that you're using the same tool for both the male and the female parts, and that you apply an allowance for the female part to ensure the two parts fit together without any difficulty. And so that completes this tutorial on how to use the Inlay Toolpath to effectively cut one part and insert it into another.